Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios once again after a short holiday. As you could see, we published a few videos, very interesting videos from previous conferences. But today we have something different. What we want to talk about is a recent study by Google regarding measuring technical debt. And as we will see, it actually links with some older ideas that we have developed related to something we call usable software design. And to help me with this, I have once again Adi. Hi, Adi.
Hello.
So, I know you didn't manage to read the whole article, so you'll play the role of the audience today.
Yes.
We'll go through the article and comment it a little bit. What we have here is an article published on IEEE Software, Volume 40, Issue 3, May-June 2023. Date of publication 26 April 2023, but only recently I've seen tweets about it and so on. So it's been quite a big thing because Google measuring technical debt, it is a big thing. And let's start with the basics. The article starts with where Cunningham introduced the metaphor underlying the technical debt in a 1992 experience report. I had no idea it was that old.
Yeah, it was because it was a system, a financial system. I don't remember what, but it wasn't a language we use nowadays. Not even Java or C++. So it was a language older than that.
I think most likely, what am I thinking about? They used to use Smalltalk. This is the one.
It could be Smalltalk, yeah. But I don't remember exactly what was the language.
And anyway, what they quote is how the company incrementally extending the piece of financial software. Mature sections of the program have been revised or rewritten many times, providing the consolidation that is key to understanding and continuing incremental development. Although immature code may work fine and be completely acceptable to the customer, excess quantities will make a program unmasterable, leading to extreme specializations of programmers and finally an inflexible product. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. And I'm going to stress this because so many times we've heard developers saying, yeah, we'll go into technical debt and then never repay it, basically. So the whole idea of technical debt was you do it a little bit because you don't know precisely what you want to achieve, but then you go back and he's talking about rewrites, but nowadays it's more like refactorings.
Yeah, I think where Cunningham explains this in a short YouTube video as well on what he meant by this technical debt, and the fact that he thought it was a good idea to ship code partially to have feedback, and he coined this term of technical debt because he said it's good to take credit, because if you take credit, you can get things faster out the door, faster in the market, but you need to start paying for the credit at some moment, as soon as possible, because otherwise your purchasing power goes to zero. So basically what that means is you're not able to add any new features.
Right. And this is what he's talking about here. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organizations can be brought to a standstill until the debt load of an unconsolidated implementation is paid.
Yeah.
So
So that's very important that we consider it a debt, but it's not just any debt. It's a debt that is in relation to your purchasing power, and that we could translate into, I don't know, how much development power you have. And if you keep doing that, you won't be able to deliver new features. You will just keep doing maintenance and hot fixes and so on, and that's a very bad situation.
yeah, and it's actually very easy to get into technical debt very quickly.
Yes, but
Uh,
very quickly we mean months, not years. So
yeah,
under a year.
days sometimes, depending on how many people you have in the team.
Yeah, to start technical debt for sure, but to get into this standstill where uh, you have just that and you cannot do anything more, you cannot purchase any more features, let's say, you can do this in months, under a
Yeah,
year for a product.
absolutely. And it's interesting. I I will go on a tangent a little bit because there is a second type of debt which is not explained here, but it's the kind of technical debt where you implement something based on your best knowledge at that point in time,
Mhm.
but that then after a few months, the knowledge has evolved. So let me give you an example. Maybe you start to do something like domain-driven design. You defined a few domain entities. You figured out what are those entities. You implement those. But then in a few months, you realize, oh, we need another entity, or that entity is not actually what we thought it was. It doesn't actually represent what we really want to. And this is another type of technical debt where the current implementation doesn't match your knowledge of the topic. Your knowledge has evolved, but the implementation has stayed the same. And when this happens, you need to go back and basically refactor to bring the design back to the current knowledge.
And I think this is the definition that Tor Cunningham gives initially, or this was the
The intent.
the purpose, the intent of this way of working. It wasn't to ship software out the door. It was, let's ship something in our current knowledge. Let's get feedback as fast as possible. We are certain that it's not perfect. And the best way to make it better is to ship it out the door, get feedback, and then reincorporate that feedback as fast as possible into the software.
Exactly. So that's the original intent, indeed. Okay, and then I really like the next part because this philosophy, the next part details of this article details the philosophy that stood behind their thinking of how to measure technical debt in Google. And it matches very well with what we've discussed for a long, long time. Because the question is, how do you measure technical debt? And you can take a very technical approach and say, we just look at some metrics. And then you try to figure out which are those metrics. But it turns out that, code-related metrics, right? But it turns out that there are very few metrics that you can use to pinpoint you to these issues. I mean, there is maybe cyclomatic complexity. You can look at fan in, fan out, some coupling metrics. But those are all, I don't feel they fully define the problem.
No, they cannot, because the problem is not in the code. It's in the distinction between what the code does and what the users expect that the code should do.
Exactly. So this is why I'm going to read this and kind of stress it a little bit, because I think they hit the nail on the head. A few things stand out about this original use of the technical debt metaphor as resonant with a human-centered approach to developer productivity. Who would have thought about, asking humans about their
Yes.
productivity? It invokes the properties of humans, for example, the ability to comprehend the product's code as an important determinant of software engineering process outcomes. It's precisely what it does. When Mark Cunningham was talking about, technical debt, it was more about people not understanding the code or the code not fitting precisely with the current knowledge.
Yes.
It frames technical debt as arising mostly from non-technical business and organizational factors. I agree with this, but I think they are missing one key point, which is the fundamental problem, the difference in knowledge. The knowledge stored in code versus the knowledge stored in people's minds.
Mm-hmm.
So it's true that it's business and organizational, but it's also the ability of engineers to actually express what they learned.
Mm-hmm.
It focuses on the practical consequences of technical debt for engineering organizations rather than merely the consequences that exist in the code. So these 3 points, I think, and particularly this idea of human-centered approach to developer productivity, how long have we been talking about this? And it took Google to figure it out.
Yeah, I don't know.
10 years.
Yeah, maybe up to 10. Yeah, so it's clearly human-centric. And I think one other metric, because you were talking about metrics, is what Michael Feathers, as far as I know, he promotes this, is to look at what code gets changed a lot. So it's not a metric on static code analysis, but it's a metric on looking at your source control repository and analyzing which of the files are changed and how often. And if you have some, let's say, class, if you have, I don't know, if you use Java or something, or some files in your software are changed a lot, it might mean that there's something wrong with that code and you have technical debt. It's not necessarily like that. It may be just an indication. So that's a very valuable insight from Michael Feathers, and I think it just points out the same thing, that it's human-centered. And I think it just tells you more where to look.
Yeah.
It's not necessarily, you cannot measure it, right? You cannot say if you have 2 files is worse than 1. I don't know. You just can start looking at it and then maybe use this Google method of measuring it.
Yeah. So that's true. And I think, to be fair, all the metrics just point to places, including the Google metrics that we'll see in a moment, just point to possible places of contention.
Mm-hmm.
It's just that in Google's case, the approach is different. As we'll see, they actually asked the engineers, what's the part of the code that is most, I don't know, we'll see in a moment how they phrase it. But it serves the same purpose, but it's interesting because it turns out that we have some static code analysis, we have some metrics on changing code, like the Michael Feathers ones, and then we have the human-centric metrics, more or less.
Which are probably best. Just ask the team.
Yeah. And we'll see. When I read this, I found it so close to usable software design. So I really, when we get there, I'll read you also what I wrote in the book on usable software design to compare it. Okay. So the next section of the article Cunningham's example of technical debt in the 1992 report is specific, but the metaphor is more general and centers on decision making and trade-offs between the speed of delivery and the quality of the product. That's not quite right, but okay, we'll get
Yeah,
over.
I wanted to say something about what you said previously, that you said that it's difficult for programmers to encode, or engineers to encode their understanding, but there's something even more difficult that we know by building products, is that you go to users, you go to, I don't know, sponsors or investors, and they say we need this product, and you start defining it with all the product management methods and so on. You have user experience, uh, you have everything that you need, and you say, look, we'll have a great product, let's ship it, let's make the MVP. You go to users, and users say, no, it's not
Yeah,
what I wanted. So even with all the measures that you take, even like that, you start having technical debt, because the overall understanding of users, of other people, of their needs, and the overall use of the best methods we know of understanding other people and what they need are not enough, apparently.
yeah, because product development is often like fishing in the dark.
Exactly. So you still have technical debt, even like that, which
Yeah,
is
but
extremely interesting and useful for any product.
to be honest, in that case, the technical part is not that bad in the sense that you just discontinue the product and forget about it. So it doesn't really matter whether the product was well written or not. Uh, but it
Yeah,
does
or
matter,
you just pivot somehow, and
or
you
you
succeed
pivot.
to get something useful out of it.
And in that case, you might have to deal with another type of technical debt, which is we build this thing for something and now we are going
Yes,
in a completely different direction. We need to
and
rethink everything.
and that's the direction I wanted to say, that this is how typically product management happens, and this is a real case scenario. You pivot, and then you go to something that's really different, and yeah, you start having technical debt just because you want to understand how to solve the problem of the people that are using it.
Yeah, to be honest, these are, let's say, very advanced situations related to technical debt. Another one that I can think about is running experiments for your product. And if you
Exactly.
run experiments, part of your product will probably be filled with feature toggles or some ways of enabling temporary experiments. And some of those experiments you need to discontinue at some point. And I don't
Mhm.
think we have a good way of doing this in software design yet. There
Yeah.
is the idea of feature toggles, but I'm not particularly fond of that. It's useful, it solves the problem, but it's not really well, it doesn't lead to good design. Let's say.
Yes, you need to redesign often. You need to make changes, refactor, and so on.
So this is why I'm a bit, but that is a more fundamental problem in the intersection between the product development and uh, software design.
Yeah.
Yeah, but in this case, I think we'll just stick to a simpler case. Let's say you know more or
Yes.
less that the product will be used. Uh, you are learning new things, but it's not they are not things that completely change your
Mhm.
direction or pull you in, a completely different domain or stuff like that. If you just take this scenario, you still can have a lot of technical debt.
Mhm. Yes,
Uh,
for sure.
okay. Over time, the technical debt metaphor has been used and misused in a wide variety of contexts and to describe a wide variety of behavior processes and software engineering scenarios. For example, Cunningham did not intend the technical debt metaphor to excuse engineers writing bad code. Of course. As a result, the term itself, technical debt, can be difficult to understand and interpret. Okay, that's fair. And now the article goes into their method. Since 2018, so this thing has been running for 5 years now.
Mm-hmm.
Our quarterly engineering satisfaction survey, every quarter is not often enough from my point of view, but our quarterly engineering satisfaction survey has asked engineers to indicate the extent to which they are hindered by unnecessary complexity and technical debt, and the percentage of engineers who feel hindered is substantial. Early on, our engineer leads wanted to know more. What is the root cause of technical debt? How can we fix it? When engineers say technical debt is slowing them down, what do they even mean? Is technical debt just a catch-all term for anything an engineer dislikes? All fair questions. These questions motivated us to systematically investigate what technical debt means to engineers, how we might measure it, and how we might better manage technical debt. We wanted to deeply understand technical debt as engineers choose to use the term rather than defining it for them, and to work on addressing technical debt from there. And this approach is brilliant. It's an empirical approach. It's human-centered. I think this is what I'd like to see for more organizations. I think
it's the way to go,
yeah. We took an empirical approach to understand what engineers mean when they refer to technical debt. We started by interviewing subject matter experts at the company, focusing our discussions to generate options for 2 survey questions. One asking engineers about the underlying causes of the technical debt they encountered, and the other asking engineers what mitigations would be appropriate to fix this debt. We included these questions in the next round of our quarterly engineering survey and gave engineers the option to select multiple root causes and multiple mitigations. Most engineers selected several options in response to each of the items. We then performed a factor analysis to discover patterns in the responses. We reran the survey the next quarter with refined response options, including another response options. We did a qualitative analysis in the description in the other bucket and iterated until we hit the point where less than 2% of engineers selected other. So basically refined the process. This provided us with a collectively exhaustive and mutually exclusive list of 10 categories of technical debt. So basically by asking people, they figure out what categories of technical debt match their environment, their product.
Mm-hmm.
And I think this is, once again, is brilliant. But before we go into the categories, let me read you a bit what I wrote in usable software design, because I find this so very close. The Google approach is much more refined, because they had access to, they have basically these teams who are doing all these things, right? You can have a research team that does that, and it's easy. And in the usable software design, what I was thinking about was more about the general principles. And the first general principle was developers are the users of software design. And because this happens, we can apply UX techniques. What are some of the UX techniques that you can apply? Well, first of all, define personas. So figure out what kind of developers you have. Okay, it just makes sense. And then the next thing is, what do you do with UX? User interviews. So what do? User interviews are great for understanding users. They imply that the designers can identify good samples of relevant users and that they have access to them. In the case of software design, the users are the developers using and changing part of the code. Since most development teams have managers, it should be easy for them to run user interviews about the software design. The main purpose of a user interview is to get qualitative information about the software design. The scope can be specific, only related to one component, or broad about the design in general. Since our team is small, I'm talking also about what I did in our case, I led continuous conversations of design. My favorite questions are, what was difficult to do in the past 2 weeks? What areas of the code were most difficult to understand? When were you afraid that your changes could be wrong? And then there are some more things, but I won't go into all of that. So this is where I say that quarterly, probably too long.
Yeah, maybe every 2 weeks, maybe every month, maybe every week. Depends a bit on the team as well.
Yeah. It's depending on the rhythm of the team. 2 weeks in our case was the sprint. So these were questions at retrospective as well. And they were part of the retrospective questions. But you see how these match exactly the same ideas, only Google came from a different perspective and we came from the other idea, but it's basically the same principle.
Yeah.
And to what I think is valuable in the approach that I presented in usable software design is that it's easier to do with smaller teams. I mean, you can do it if you are not Google.
Yes, of course.
And much smaller than Google.
You just need to understand a bit of UX, which is not that difficult. And I think you start having some results.
Yeah. Okay. And so to finish with this, because the next part is basically the conclusion of this article, they identified 10 categories of technical debt. First one was migration is needed or in progress. And this could be migrating from a technology to another, scaling things up, things like that. Documentation, hard to find, missing, or incomplete. Yeah, we know that is a big problem usually. Testing, poor test quality or coverage, fragility, flaky tests, and so on. We know this as well. Code quality, product architecture or code within a project was not well designed. It may have been rushed or a prototype demo. Yeah. Dead or abandoned code. Just delete it. Code degradation. The code base is degraded or not kept up with changing standards over time. Team lacks necessary expertise. Absolutely. Dependencies, unstable, rapidly changing or trigger rollbacks. Migration was poorly executed or abandoned, which may have resulted in maintaining 2 versions instead of 1. Release process. Rollout and monitoring of production is to be updated, migrated, and maintained. We continue to ask engineers every quarter for the last 4 years about which of these categories of technical debt have hindered their productivity in the previous quarter. Defying some expectations, engineers do not select all of them. In fact, about 3/4 engineers select 3 or fewer categories. Yeah, I find this expected because it's the 80-20 rule, right? So 20% of the causes will cause 80% of the problems in this case.
Yeah,
so,
for sure.
And it's exactly that. So they select 3 or fewer. I mean, 2 or 3. 1, 2, or 3, which is basically 20% on average. So, which forms of technical debt did you okay, it's worth noting that our survey does not ask engineers which form of technical debt did you encounter, but only which form of technical debt have hindered your productivity. It's well understood that all code has some technical debt. Moreover, taking on technical debt prudently and deliberately can be a correct engineering choice. Engineers may run into more of these during the course of the quarter, but productivity may not be substantially hindered in all cases. Okay. And apparently, but this is more specific to Google, like migration seemed to be a big hindrance and so on. But this is more specific to them. And so basically what they did, they took these categories and measured them and figured out that there are 3 of the 10 types of technical debt: code degradation, teams lacking expertise, and migration being needed in progress. And went into more details, but didn't get any didn't get a single metric that predicted reports from these engineers.
Okay, interesting.
Yeah. So I think that okay. This is the part that I like to read again. While we haven't been able to find leading indicators of technical debt thus far, we can continue to measure technical debt with our survey and help to identify teams that struggle with managing technical debt of different types. To that end, we also added the following questions to our engineering survey. To what extent has your team deliberately incurred technical debt in the past 3 months? How often do you feel that incurring technical debt was the right decision? How much did your team invest in reducing existing technical debt and maintaining your code? How well does your team's process for managing technical debt work? Now, honestly, I find that when they go into these types of questions, the error margin becomes larger.
Yeah, these 4 questions are kind of difficult to answer.
Yeah.
They're very open, but also very abstract. And if I'm thinking at the 3 months, it becomes even more difficult. I don't know. 2 months ago, how much we invested in existing technical debt and maintaining the code. Tough to say.
Yeah. So my approach, which is the one that I described in the book, was a bit different in the sense that we were discussing every 2 weeks about the parts of the code that were the most prone to errors. Because basically, so let me go back to this. Usability is defined as being about 5 design qualities. Learnability, how easy it is to accomplish basic tasks the first time you're using the design. In the case of software, this would be like a new member in the team. How fast can they be productive? Right. That's basically it. Efficiency, how quickly can you perform the task once you've learned the design? So if there's a team member that's been in the team for longer, and you have some categories of tasks, for those tasks, how you basically can measure the cycle time and figure out if you are doing those really quickly or not. Memorability is basically about if you take a holiday and then come back and you still use the design. But then errors and satisfactions are number 4 and 5. Errors, how many errors do you make? Which is basically how many bugs can you introduce in the code or at a certain point in time, right? Because this is, but it's also about the development flow. So how many times do you need to iterate until you can implement a task, right? Do you write some code and then you figure out that it's not exactly what it needs, and now I need to change it a little bit because I need to use another class or things like that. So there are two levels here. And then the last one is satisfaction. How pleasant it is to use the design. And basically what you can do is to ask people about errors and satisfaction, because the other things you can measure. You can measure them like the time for a new team member to get used to the design. That's something that you usually know. Usually I'm very surprised, because for many teams it's like 6 months or 9 months, which is huge.
Huge. Yeah. You forget what you've done, so you need sometimes to relearn what's going on there.
Yeah. And so learnability, but basically you kind of know that. Efficiency, you can measure it using cycle time, if you're doing something like Kanban or something like that. But for the other things, you need to ask. Well, errors, you can measure the number of bugs, but that's not enough, because you also have errors refer to the experience of a developer while writing the code as well. And that you need to ask them, because otherwise you won't find it. So if you start from this model, there are two basic things that you need to ask. And one of them is, what are the areas of the code that were, least satisfying, let's say? Maybe don't frame it like that. You can frame it like most difficult to work with or something like that. And about errors, when did you felt like you couldn't get into the flow of development because you kept getting blocks from the design? Mm-hmm. Basically, the code design was hitting you back and pushing you back. And if you take these two, then you can look at those specific areas and figure out what is difficult and basically pay the technical debt. And oftentimes it's just a matter of renaming things. Sometimes it's more complicated, but maybe you need to add some documentation. Maybe you need to rename some things. Maybe you need, to optimize a little bit. But from our experience, it wasn't that hard to do. It's just a matter of paying continuous attention to these things. Right? And I feel that this approach is much better. I understand that they are trying to find some leading indicators for technical debt.
Yeah.
It's an interesting...
They didn't manage to do.
Yeah. Yes. It's definitely an interesting thing if they manage to do it, but I have my doubts. I feel that there are so many possible causes that it will be hard.
Well, if they can measure entropy, then maybe.
Right. Okay. So I won't go into the rest of the article. Because there are a bunch of solutions here that they picked and so on. But these are very specific to Google. And so I think that most of the value of this article lies in the fact that you can take this method, adapt it a little bit, and apply it to your organization to figure out what are the types of technical debt that you have as an organization, and how you deal with those. But fundamentally, it starts from asking your developers.
Mm-hmm. Yes, exactly.
All right. I think we'll stop here. Anything else you'd like to add before we close?
I hope people stop considering that technical debt equals bad programming, because it's not that. And quite too often when I hear people saying technical debt just because someone didn't know how to use the right type of collection for I don't know what. Well, that's not really. It's not the initial intent of this concept of technical debt. That's
Yeah.
just bad programming, in my view.
Yeah, so even if you take, let's assume that you have the perfect developer who can perfectly express the knowledge about the code, the knowledge about the feature in the code. Even in that case, you'll have technical debt
Yes.
because knowledge evolves in time. So that's a fundamental problem. And then there are all the other factors like technology changes. Okay, well, we are using Spring, I don't know, version 12, and now we get Spring version 13, and it breaks some things, or we are using React version 5, and now it's version 7, and we really need to switch to version 7 because some of the things don't work anymore, and all this kind of stuff. So there are there's also some accidental part. In this thing, which is inflicted by other developers, basically. But there's a fundamental part which is related to knowledge and how it evolves in time. But I think
Yes.
the important part is to pay it very quickly, right?
Yes, as soon as you find it. And that's important to find, to look for it, because sometimes you just don't know.
Yeah.
So you need to look for that, and you need to understand where is your technical debt, and to be proactive about this.
Okay. So if I can make a few recommendations, check out everything that Wirt Cunningham has ever done because he's basically a genius, and he had a lot of interesting ideas. Many of them are on the wiki, which he also invented, on the original wiki. And you can find a treasure trove of ideas there about software, software design, and all kinds of things. Martin Fowler has some articles about technical debt, which is really good. Michael Feathers, of course. We mentioned the metrics related to code changes. And I think, I really hope that usable software design will start to, as slow as it might be, I really hope that it will start to become something that's used. Because I feel it is a fundamental, it's just something that makes sense. Once you start thinking about developers of users of software design, then it makes sense to start using UX to improve their experience. But it might also be that everything will get hijacked by AI. So who knows?
Who knows?
Yeah. All right, Adi. Thank you for being keeping the place of the audience today.
Thank you as well.
And we'll see you soon, I hope. Well, that's it, folks. So we talked about technical debt. I'll add in the description links to some of the things that we talked about. What do you think? Let us know in the comments. What are your experiences with technical debt? Do these things make sense? Would you like to learn more about usable software design? We have a few videos on this channel as well. But if you have any questions, yeah, let us know. Thank you kindly for the view, and until next time, remember to think, design, and work smart.